Let's begin. So, ladies and gentlemen, we are now to the final ride of our syllabus, Form 2. Yeah. In chapter 11, you've learned about the sun and how the sun was born, the birth of the sun and the death of a sun, or we call it a star, the birth and the death of a star. Chapter 12, last Saturday, we visited the planets, correct? We visited the planets in our solar system. Today, we are going to still look at the same solar system, but we will explore other things. Now, there are other things besides these planets and the sun. So what they are? First, we will explore, okay, rocks that float around here. They are tiny little rocks that float around here and there and everywhere. And these rocks just go with the flow. Yeah. Now, these rocks, we call them meteoroids. Later we'll see. Okay. And there's one rock here. Another layer of rocks we're going to see are rocks that are found in between the 4th planet and the 5th planet. Anyone remembers what is the 4th and 5th planet? What's the 4th and 5th planet called? Don't know. Hey, Mars and Jupiter, correct? Don't know. Okay, Mars and Jupiter. And then next, we can look at even bigger ones. And this one has tail. All right, these are called comet. So today we look at these 3 other things that are also found in our solar system. Okay, now we're going to start off with the first one. Right, the first one we call this. First ones are this, the free floating ones. Now there are always one person in your group of friends, right? Where you have one person who is the 你要去哪里? Where do you want to go? 青菜啦, 洗蛋啦, okay, 随便啦, okay, correct or not? Anything lah, right? You have that anything who go with the flow one. The group go here, they will follow. The group go there, they will follow. These are the meteoroids. Now, why is it so? Why do I call them like meteoroids? Why are they like that? Like the anything, anyhow kind of people? Okay, because this meteoroid, how they move, right? They do not go around the sun. They don't have a special path to go around the sun. They can go like they go around the sun, and then if there's another planet nearby here, they will be drawn to the planet. And then that planet go there, they will be pulled there. So this one pull here. Hey, I'm here. Oh, okay, I come over here. So they'll be pulled left, pull right, pull left, pull right. So they just go with the flow. Understand or not? These are called the meteoroids. Any of you are meteoroids in your gang over there? Or you're the one who decides? So meteoroids, let's start. Okay, meteoroids do not have tail. Meteoroids do not have tail unless they hit the earth, which we will see later. All right, so please highlight, students, we need to know what is in meteoroids and asteroids and comets. Yeah, first and foremost, please take a highlighter and highlight meteoroids are rocks and metal. Rocks and metal, so they are made up of stone and metal. A lot of iron, a lot of nickel in them. Yeah. Now, where do they come from? They come from all these pieces of asteroids. You know, asteroids, they knock into each other, then small pieces. Now, next thing. How big can a meteor be? How big is it? Now, let's look here. First point. It can be as small as a sand. Anyone put like that? Your finger like that? This small. Meteoroid can be this small. Yes. And meteoroid can go up to 1 meter. Now, how big is 1 meter? How to use your hand and show me, all right, how big you think is the 1 meter, right? Now, if you want to estimate how long is the 1 meter, you know your mathematics teacher, she uses that long 1 meter ruler, all right? Put your hand around this height, this size, all right? Put your hand around this size, right? They said, hey, this is 1 meter. I think no, it's bigger, actually, it's bigger, okay? The 1 meter ruler is way longer than this. So, 1 meter. Now, this is how big a meteoroid can go up to. Right? Is it dangerous or not? Of course lah, guys, this is a big stone. Throw at the person head will pecah, I tell you. Correct lah? Yeah? So, highlight made up of rocks and metals. Okay? Now, highlight this. They move freely in space. You see, they are the Chin-Chai people. They are the anything lah, 随便啦. Okay? There. Okay? So, how do they move? They are influenced by the planets and moon's gravity. So whoever pulls them, whoever's planet or moon that is near them, they will get pulled, they'll move to that direction. Understand? Now, next one. The speed difference, the speed varies between all of them. Now, look at this point here. The fastest one is 42 kilometers per second. This is fast. Do you think 42 kilometers per second is fast? Yes or no? No. All right, so let's do a demonstration. I want everyone to hold a hand up like that. Use the hand. And I want to do a hand that is on a fist punching one. And then this hand is 1 meter away. Just imagine 1 meter away, which is roughly the length of your teacher 1 meter ruler. Done, huh? Okay. Now, once you do this, okay, I'm going to count 1, 2, 3. And on the 3, I give you 1 second. You try to hit as fast as you can from this thing to your palm. Let's see how fast you can hit in 1 second. All right, so I want all of you to lift your hand up like that and go. Okay, ready? 1, 2, 3, hit. No one is doing it. Hello? Hello? Why is no one doing it? Okay, one more time. All of you put your hand like that. Dylan, are you there? Further. Dylan, too big already. Slightly smaller. Max is too small already. 1 meter leh. Wow, the 1 meter ruler is longer than that. I'm doing. You can't see me. Okay, I like that. Okay, ready? I count to 3. I give you 1 second to hit that palm over there. 1, 2, 3, go. How fast you can hit? Okay, hit too fast already. All right. So, students, this is only sakit. This is only 1 meter in 1 second. Now, how fast is this meteorite moving? 42 kilometers per second. That means 4,200 times of your hand width. Just now, this is 1. Imagine I times 4,002. In 1 second, instead of reaching here, in 1 second, it has reached 4,200 of my hands the other end already. That is how fast it moves. Fast or not? Now you tell me. Okay? So it is so fast that from here you can travel up to Kedai in 1 second. Okay? So that is the speed. Now, next up. Let's move to those who know their path. Wow, this friend very fast. Yeah, this friend very fast. Yeah, this friend very, very fast. Okay, now we're going to go into the nice, beautiful rocks that are found in between. Where is it? Okay, rocks. This is tiny little dots of rocks over here that are found between Mars and Jupiter over here. We call them the asteroids. Now, students, you need to know what is found in asteroids. Look here, rock and metal. Same as who? Same as the meteoroid, correct? Now, how big now? How big can an asteroid be? 1 meter can reach up to 1,000 kilometers. 1 meter from here, this is the minimum size, the smaller size. The bigger size is 1,000 kilometers. Now, how big is 1,000 kilometers? Well, if you to see from from Perlis to Johor, okay, is roughly 650 kilometers. Okay, so this one is 1,000. So if this 1,000 hit Malaysia, bye-bye, got already. Singapore can follow us also. Yeah, so next. Sometimes they call it planetoids. Planetoids means small planet, just a small tiny little planet, but they still wouldn't call it a planet yet. Yeah. Next, again, as I said just now, it consists of metal and rocks. Please highlight that. Now, this next part is about the category C type, S type, M type. That means what they have inside. Yeah, this is a giant friend. Yeah. Now, next thing, right? You see the speed. Just now was 42 kilometers per second. And look at this speed now. Is it faster or is it slower? Is it faster or slower? 25 kilometers per second is slower. Nearly, roughly less, around half or slightly more than half. Correct? The speed. Can you see that? Zenyu, are you there? Testing only. Zenyu, are you there? Zenyu. Testing. Okay, you're there. So where can we find asteroids? Asteroids are found in the belt. We call that asteroid belt, and it's found between Mars and Jupiter. I'll show you some videos in one. Yeah. So and then humans have no other. Humans just want to see. Wow. Okay, got a few asteroids. Let's give them names, and then humans give them names. All right. You have Ceres, Pallas, Puno, and Vesta. These are just humans naming them. Now, let's look at this one. How big is this? This one, just now you say the biggest asteroid is nearly one Malaysia plus Singapore size, 对吗? This one is 250,000 kilometers. Huge. If this one hits the Earth, what do you think will happen? Okay, bye-bye. We are gone already. Yeah, I'm going to show you a video later on what if a comet hits the Earth. All right, we're going to watch that video. I know students like all these hypothetical questions, right? What if, right? Okay, so comets. Now, comets, they are found further away. They are from this is Neptune, right? This is Neptune over here. Comets are found from this region. We call it the Kuiper belt or Kuiper belt. All right, with a lot of stones, and then further out there's ice. So they travel from very far away. So knowing that they are very far away means very cold, right? No heat over there, right? So they're very, very cold. So what are they traveling? They are a block of ice traveling. Okay, it's like ice delivery like that. So what are they? So it's highlight. Okay, they are made up of gas, ice, frozen dust. So think of it as a very, very hard, dense icy material. Okay. Now, and where do they travel? They travel around the sun. So please highlight this one also. Wait, I think that's okay. Never mind. I want to add over here. Okay, travels in an orbit. Okay, right, for this one, I want to add points. These are the exam questions. Does not travel. Does not have an orbit. Does not have. Orbit means the path that they move around because of gravity of the sun. Does not have. The other one travels in an orbit. This one also the same thing, travels in an orbit. Next thing, students, how do I differentiate comets with the rest? Comets have a tail, right? So why do they have a tail? It has two parts. You see, there's a head and there's a tail. So because the head is made out of ice, and then the sun is here, the heat is coming from here. So when I travel towards that direction, what do you think will happen to my ice? Will they melt into water? They won't, right? Because the heat is so strong, all right, and the friction is there. So what happens is this ice will evaporate to become vapor. So this will create like a tail. So the tail is actually the evaporation of the ice as it goes closer and closer to the sun. 明白吗? Yeah? All right. So your school teacher teach you, right? This one? Or your do presentation, sorry. So let's highlight here. 250,000 is the head. The tail can reach up to 150 million. Do you really need to know the names, the numbers? No, you don't need to know the numbers. but at least you need to know the size of it, right? Meteoroid, asteroid, pole, and then you have comets. Understand? Now, the speed depends. It has an average of 10, average to 70. So it can be as fast as a meteoroid. It can be faster than meteoroid. It can be like asteroid as well. Yeah. So what do we learn from this part here that is important? Please put a star in this part. Yeah. Can you tell me, if I ask you first thing, can you find out what's the difference between meteoroid, asteroid, and comets in their composition? What's the meaning of composition? What are they made up of? Can you find it? Fine. Okay, let's do a bit of a latihan here. Right? Rock metal, rock and metal, and then the bottom one, ice, frozen dust, gas. 可以吗? All right. Next, what other ways can I differentiate these three? What other ways can I differentiate these three? I differentiate based on their what other ways I can differentiate them? Anyone? That's all. I can differentiate them based on what they're made up of only, is it? Okay, based on their size, right? Based on the size. Yeah, so based on their shape, can. And based on whether they travel in an orbit or not. Understand? Yeah. What else? Whether they are influenced by the gravity of other planets or not. You see, this one is influenced, these two not influenced. Okay, so the comet will come from here. It will travel, this comet here will travel around and go one round over. Brightness can not cover in the syllabus. Okay, so we don't try to avoid that. Okay, now brightness usually you use for stars because they are the one that emits the light. You see, these three don't emit light, so we don't use brightness to measure them. So we use size other ways. Okay, so now let's move into the next part over here. Now that you understand, you know how to differentiate between meteoroid, asteroid, and comet, right? We're going to focus one by one. We will look at meteoroid first. 我们看这个 meteoroid 先. Okay, now meteoroid, you know that friend that anyhow, chinchai, anything, I go with the flow kind of friend, right? Now, this meteoroid can change name in different location. Huh? Means what? Yeah, they can be anything, they can be chinchai, they can be 随便, right? So let's see what names they can change and how do we differentiate them, right? We're going to start off with meteoroids and zoom a little bit deeper into this floating rock in space. Rock and metal. Yeah. Now, this is our beloved Earth. All right. A rock that is floating outside, we call it as it is meteoroid. But if this meteoroid gets too close to Earth, they will enter our Earth atmosphere. And then when they enter the Earth atmosphere, they will start to be slowly burned off. They will slowly be burned off by our layer of atmosphere. Now, does anyone still remember in geography, I think, or science form 1, that you learn that there's a layer of atmosphere, one of the layer in the atmosphere that the comet or the meteor is fully burned out. Anyone knows? Forget that. It is called the metaflora, very close. Okay, mesosphere. Okay, mesosphere. So in this area here, when the meteoroid is slowly burned out, it will create a tail. Correct, not? So scientists call this meteor. So if meteoroid enter the atmosphere, we call it meteor. Understand? Yeah. And then if the meteor hits the Earth, boom. Now we call this a meteorite. Understand? Yeah, meteorite. So one more time, meteoroid. So I teach you a small little paper. I use in Bahasa Melayu because I can't find the English. I can't figure out the English way. All right, meteoroid D. Okay, di luar. That means they are floating outside. All right, R for meteor. Where is it found? It is found in our ruang atmosfera. And meteorite, there's a T, right? The T sounds a very heavy pronunciation there, meteorite, right? The T means tanah, means they hit the ground already. Okay? Meteoroid, di luar, meteor, they have entered the ruang angkasa, ruang atmosfera, enter our space, and then meteorite, T, has hit the ground. Now, do you think any meteorite ever hit the ground? Teacher, no need so complex, not very easy. See, then no. That's all. I thought you have your own paper to introduce. Oh, okay. Don't have. At least for a lot of students, because I know you got 9, 20, 10, 20 subjects to study, correct or not? So sometimes certain things that make you understand better, then okay lah. Right? If you love science, then of course, you don't have to find ways to memorize. You will know it because you like it. Correct lah. Yeah. Just show you. (2013), if not mistaken. Was it 10 years ago? 10 years ago. All right. Just to show you. Have you seen this video before? So there's a meteor.
Нихуя себе, это что такое?
Ground.
О, нихуя метеорит, блядь.
Внимание,
Ебануться. Нихуя себе.
Life just normal like that, right?
Я сейчас подойду, подожди. Я себе.
It's the same location from different angles. What would you do, right? Can you imagine driving like that and then suddenly a burst of light just appear in front of you, right? So yeah, it hit Russia back then. Right? China also got hit, I think. What's the name? You something, that place. Germany. Don't have something in you. I really hard to find this. I remember I see one time. I forgot where is it? Yeah, can't find it. I have to check back again. I don't think it's this. Is this the one? (2023). 2 months ago.
UFO 吧？我操！
Wow.
On June 13, 2023, at 1:28 a.m., unknown fireball seemed to appear in the night sky of Beijing, China. That fireball looks big and bright. Many witnesses wondered what it was.
Correct, there's no way to escape. Rock there.
Some people say it looks like a large meteor. In fact, it is the scene of second stage wreckage of the Chang'e 2F rocket that launched the Shenzhou 16 on May
So apparently it's a rocket.
30th, re-entering the atmosphere and
According to them, it's not meteor, it's a rocket returning back. Then why would they put as meteor? So misleading. No, it was another place that I saw the China video, to go and correct first. If I find it, I let you know. Okay, now there you have it. What do you need to know about meteor? That's all. Okay, the 3 different names of meteoroids. Now let's move into asteroids. asteroids, they move in their own orbit. Is there a way over here? Never show you. Okay, so the movement of asteroid. Okay, so the average speed is 25 kilometers per second. That one we explained just now. There are also asteroids that move around the sun. All right. So if you notice, not all asteroids follow in their own belt one. You see, this is the belt, the range between here. This is the belt, right? There are some who go a little bit off from the belt. You have this. This is us, This is us. All right. This is our Earth. All right. Now look at other asteroid with their orbits. We have asteroid Amor. Wow. All right. Asteroid Amor. This circle over here. Do you see that? Does it cross path with Earth or not one day? Right? It crosses with the Earth orbit a little bit. And then we have Apollo. Where is Apollo? Apollo is here. Apollo's orbit go and crosses with the red color one. Oh no. So will there be a time when the Earth and Apollo meet each other? Boom. Yes or no? Low chance. Correct not? So we are expecting asteroids to be hitting the Earth, but NASA, they are working towards how to distract that asteroid. Right? So what do you think? What do you think you would do? Let's say if you know the Earth is moving here and the asteroid will be also moving here. What plans do you think you would need to do? What would you do? I just gonna like, oh no, let's just pray. What do you think we'll do? Anyone? NASA is seeking ways right now to send spaceship upwards and to try to collide with the asteroid in hopes to turn its spin so that it doesn't hit, it goes on a different direction instead. Missile, right? Some people say we nuke it, we send nuclear bomb to explode. Yeah, send missiles, correct? And the missile must be strong enough to go all the way up. Yeah, so this is just to show you a little bit on the asteroid over here. Now, next we move into comets. Now, where do comets come from? Where do comets come from? Now, ladies and gentlemen, we learn about the solar system. This is us, Earth. This is the Sun. And this is the end, Neptune. But what is further above Neptune, further outer than the Neptune? We have a belt of rocks called the Kuiper Belt or Kuiper Belt. Yeah, full of rocks over here. So it's not the end of our solar system yet. So we have a belt over here. And then further out from this Kuiper Belt, we have a cloud called the Oort cloud. It is filled with icy rocks. Okay, a lot of ice over here floating. So this is the Oort cloud. Passing the Oort cloud, this is the end of our solar system. And then if you can pass through it, then you're going to go near further somewhere, you get to see another solar system. Okay? So, next up. This one, explain why is there a tail. Why got tail one? Well, the comet, as they move faster, the comet, the ice begin to melt and it forms what? Vapor. It creates the tail. That's number 4. Right? Now, number 5 is important, ladies and gentlemen. Okay, let me ask you here. Let me just go back to a small little drawing here. Let me use up this space here. Okay, this is the sun. This is the comet, comet path, the path of the comet. Let me show you here. Okay, I'm going to draw one comet here. I'm going to draw another comet over here. I'm going to draw another comet here. Oops, another comet over here. And another comet over here. The direction of movement is this way. Okay. Next is I ask you to draw. how will the tail look like? How will the tail look like? For this position, easy, because I'm moving towards the sun, my tail will be backwards like that, correct? Yes, no? Now, how about here? Tell me, is it A position, or is it B position, or is it a C position, or the tail will go towards a B position? Type in your answer. A, B, C, or D. Okay, so D. So the answer is, as it moves towards here, as it moves towards this direction, we thought the tail would be like this, correct? Like this, correct? In actual fact, it is not. It is more towards this direction. Why so? Because the heat from the sun, the wave or the heat wave from the sun is hitting this direction, and the melting, because of the movement there, it pushes the tail towards that direction. Easy to see is, just imagine all of you have long hair. I know boys, you got no long hair. I give you a fake long hair, all right? And I'm going to put a giant fan over here. And this fan is going to blow in all direction, correct? This fan over here. Yeah, and then I'm going to ask you to walk. As you walk towards this direction, your hair will be backwards, correct? As you walk towards there, but the fan is blowing this way, your hair will still blow that direction. Yes, no? Can you imagine now? Yes? So over here, as I walk here, wind blow, hair, this direction. 明白吗? Over here, here, so slightly more towards this direction, but I'm still moving that direction. Understand? Yeah, so please do not make mistakes in this. There. You see? So as I move this way, the flare hits my tail this direction. Am I moving here? Over here, I'm still moving there, but my hair goes that way, and so on, so forth. Understand? It keeps hitting, and just imagine shooting out from the sun. This is where the tail is going to be. Okay, yeah. Don't forget this part. Okay. Next up. So far, don't worry. There's no proof that comet will hit here. By the way, in 1986. All right. Comet, because they're so far away and they travel, comets, they travel very far away. Earth is just around here. Sometimes we cannot see them because this is not like, you know, your neighbor's house within distance, right? This is huge, large of kilometers away. So these comets, they rarely come to a point where Earth can get a chance to see it. So the last time that Earth can see a huge comet, remember how big is a comet? 250,000 kilometers wide, right? The last time we saw it was in 1986. Anyone? You guys are negative. Negative how many years old, right? So 1986, that is 37 years ago, correct? Now, expected. Say, teacher, will I see a comet again? Well, based on the calculation trajectories and all, we are expecting to see it coming back again in 2061. How old will you students be? Can you tell me how old will you be in 2061? Wow, guys, this is not difficult maths, you know. Hello, hello. I don't know, but I maybe can see no. Yishin, you don't, I don't know. Type out now. I want you to please calculate for me. Why some of you give me 52, some of you give me 53. Which is the correct one? 2061. How old are you this year? 2061. Do mathematics now. Count. Using calculator. I go find calculator. Use your finger, use your pen, pencil, right? Also can. Max say 52. Then you say 52. Correct. All right. You should find your calculator now. Okay. It's 52 years. No, you know, you tak ada brain. You malas want to ambil calculator. No, don't say tak ada brain. All right, so you guys will be 52 years old. Wow, guys. You would have experienced a lot of things really. And you can finally see a comment. Now, spelling over here, please change the spelling. Meteoroid, not meteoroid. Okay, next up. Let's watch a what if. Remember just now the comet's name is called Halley's Comet that you will see in 52 years when you're 52 years old, right? Okay, so just a little bit of a visual for you to see. 11 kilometers only, guys. How big is that? To Mid Valley, maybe for some of your house. All right, Mid Valley is actually closer. All right, for some of you stay in Puchong, maybe slightly more. You know, it's lesser than that some more. All right, it's bigger than that. But it is not a 1 kg thing. It's 220 trillion kg. Yeah, very dense. July 2061, it wasn't 2060. Okay, let's stop here for a while. Hit a small part only, one. Correct, right? You watch this one, it's just a small part. 33 km. How wide is 33 km? Right. Right. Google Map. Let's take whose school? Allow? Don't allow? All right, let's just take Sentosa School. Since it's in Kuchai Lama and most of you actually know half, right? Okay, let's just take Sentosa. Directions to KLCC. This is only from wherever you are, let's say Kuchai Lama, Oakland Road, all the way there is only, actually it's less than that. All right, it's only like 8.4, 10, 11 km. Yeah, so it's not Mid Valley just now, sorry. Mid Valley is way further. It's way nearer. So this to KLCC is only 11 kilometers. This thing will hit for 33 kilometers. So if you times 3 the length, right? So it's gonna hit a huge crater that covers here, this whole area. Gone. Let's say if it hits here, but of course, very low chance. Okay, so from now we're going to start to see how does it affect the other parts of the world. Because it's, let's say it's going to hit one part of the world anyway, correct? Will it affect the other parts of the earth? So let's see, how does this kill everyone else that is not hit by the crater, hit by the comet? Pardon, 吓死人. All right. So there you have it. This is just one of it. If you watch YouTube, any of you here like to watch YouTube? I don't know. I like to watch YouTube a lot. For me, I learn a lot by visuals, right? Yeah. I prefer listening and then watching videos than reading. I'm fine with reading, but I still prefer watching video and visual. Yeah. So please make use of YouTube, right? It's just so much to learn from. So many what ifs. There's this channel called What If Science. Whoa, you can surf for a whole day of questions of what we call hypothetical question. What if I put you in Neptune? What if we land on Titan? What if we go to different, yeah, I watched a black hole. What if we fall into a black hole? So many great animations nowadays to let you visualize things that you might not have imagined. Okay. I watched the What If Earth Don't Have Oxygen for 5 seconds. Yeah, I saw that. Nice. Good. Now, asteroid, comet. What can we do? Protecting the Earth from asteroid. So underline this. What can we do? Well, in 2013, National Aeronautics and Space Administration, NASA, stated the probability of this asteroid called Apophis asteroid. Is it shown here? Is there Apophis here? Never show Apophis in this list here. All right. Apophis will hit the size of 3.5 football field, hitting Earth at 2036. That's like 13 years from now. All right. Now, what are we going to do? Well, these are few 5 steps that you can do to prevent impact of asteroids. Yeah, first and foremost, find them. Of course, we need to know how to locate them. We need to find, oh, okay, that asteroid is hitting the Earth, right? First of all, you need to find the asteroid. Now, after we find the asteroid, oh, this one is coming here. What do? You're going to track it along the way, right? So you're going to track the asteroid movement, predict using mathematics. Okay, Yishin, use mathematics. And then, still got time. You see, track with them. Okay, the asteroid is coming. Okay, let's characterize it. Let's put them into, characterize, okay, what size is this? What's the composition? What is inside this asteroid? Is it more of metal? And what kind of metal will there be inside this asteroid? So a lot of things, okay, spin rate, composition, physical properties, everything we need to know. Next is deflect it. Deflect means try to move it away from its original path, right? Asteroid, we try to deflect it from hitting the Earth. So a few things, it's quite weak over here. Laser radiation to deflect the path using laser, all right, and hopefully shoot enough energy, which is quite difficult to achieve that amount of energy. But if you shoot enough energy, you should be able to turn the spin of the asteroid. Yeah, theoretically. Okay, some students say, teacher, use laser to deflect means what? Is it like how I used to put the laser and then attract my cats like that? You play laser and then the cats will follow. Ayo, I got students like that one. Okay, next, sending an aircraft. Anyone? Okay, willing to sacrifice? We send an aircraft. This aircraft is special in such a way that they will create a gravity effect. That means this aircraft, the asteroid is coming here, this asteroid hitting Earth, right? This aircraft come here, and then it creates a gravity impact that will deflect the asteroid sideways. Like, oh, you can do that? Okay, but how are you going to create such strong gravitational pull there? I'm curious. All these are very theoretical. Yeah. Next, kinetic impactor, sending 2 or more spacecraft to slam into the asteroid. Boom, langgar the asteroid. Or sending nuclear bombs to break it into smaller pieces in case it fall. Right? So if you send the nuclear bomb, right? You send the nuclear bomb. So the nuclear bomb must be strong enough lah. Must be able to move fast enough. You know, after that you send, and then gravity pull back, the nuclear bomb fall back to us. Ayo, then we gone already. Okay, next up. And lastly, we give education. Educate, tell the threats of asteroid from every stage. Okay, disaster management, all this. All is money. Of course, all is money. So either you spend your money on that, or you enjoy the impact. Correct. Okay, so there we have it. What is more important in this chapter are the first few pages, this one. All right, the differences between these three, students need to know. Next thing, the many names of meteoroid as it enters the earth. And lastly, the position of the tail. Yeah, all these are famous WASA questions. Okay? Now, what's the time now? We still got time. Break. Okay, fine. I'll give a break. Holiday, just to let you know first. During the holiday, I will give you guys latihan set to do, right? And then with the answers together, because I scared got not enough time. So in case you want to expose yourself to more questions, right? The more questions you expose yourself to, the easier the questions become. Correct or not? At least you know, oh, I answered this question before. I know how to answer this kind of question. They require this kind of answer, right? So I'm going to send you samples to do, and you do it to expose yourself. Understand that? Okay, now let's go for a short break. Now it's 9:50. We come back at 9:53 p.m. Any questions? Hey, chapter 11 haven't yet, chapter 12 haven't yet. So for example, if next time I buy latihan books to do, okay. How to know which is better? Go for trusted brands. Yeah, Pelangi, Sasbadi. These are more, yeah, Pelangi or Sasbadi lah. Okay. You never buy any before. Yeah. Buy them because textbook writers usually hired by Pelangi and Sasbadi as well. Okay. But if you're familiar, if you know better, right, you can actually Pelangi and Sasbadi, Sasbadi. If you want better, right, let's say you want to buy geography text, geography revision book, then you look for the textbook author. There's a list of author that writes science books, that writes geography books, right? Look at the names, and then usually I will maybe buy one sample of their book lah. All right. So if I will look at the name, and you see lah, textbook writer, they will come out with their own version of latihan. You see their names matching one. Okay, then maybe you can get that because they're the one who write the textbook, so they would know the content a little bit better. Yeah. But of course, for science, I always go for this writer called Gan Wan Yan, who's been writing science books since my time already. Okay, so if you can find this person's border, whether still got or not for science lah. Right, these are the few trusted that books I will buy because it's challenging a little bit. If you want even more challenging, look for this publisher called SAP. Whoa, this one is sometimes the answer is out of the textbook one, but it keeps the student thinking a little bit more. But for a good start, go for Pelangi and Saspadi. Yeah. And for a good start as well, look for formative exercise. Summative and formative are two different books. Formative is by chapters, or they put topical. That means chapter 1, chapter 2, chapter 3. Summative is the whole year. Set 1 paper, set 2 paper. Okay, set 1 the whole of Form 2 syllabus. That one is more on summative. Yes. Great, great, great. Good to know that you want to improve. So summative is model paper. Yeah, summary ma. Summative summary of the whole year, right? Yeah, formative, like by they form your thoughts chapter by chapter. No, you see, you know already lah, but 1, but 2, but 3, but 4, you know it's formative already, right? It's quite easy to see. Good, good, good. Keep it up. You still have time, all right? Are you targeting to enter science stream, Norfei? Any of you here targeting to enter science stream? Actually, right, why not? Why not you guys, try to plan, but you, Zenyu, all right. I don't think I can, but I have to. Let's see, why you have to? Mummy force all right. Well, yeah lah. Science stream opens up, okay, for those, for those who need motivations to start for Form 3. Science stream opens up your possibility, right? You can work in science field, you can work in arts field as well. Lowest B to get science, yes. Science, mathematics, English. Is it English? And BM. But mainly this four. C is your goal. You want to get C for science. After tuition with me for the whole year, and you want a C for science, how do you think that makes me feel? And how can you how can you look at yourself and tell yourself you're a basic Kenny student? Get a C for science. After 3 years already, you follow me. 哪里可以? At least a B. B mine also I happier. It's not hard. You do homework or not? Tell me which are the students who pass up my homework. I know what. I know which student hand up the homework and send to me WhatsApp every week. I know who. I haven't seen your homework yet. So next year, please, if I have to go to science stream, right? Sore throat now. Dylan auto science already lah. So, what I like about science stream, of course, both streams have their advantages. Definitely, you learn about accounting, you learn about economics, how the country is run. You can learn that. You can also learn that if you're in science stream as well. But I like how the science syllabus is arranged in such a way, the science stream, in such a way that they train your problem-solving skills. They really train your critical thinking skills. Yeah, that is the advantage of science stream. That is the scope of science stream subjects. Yeah, difficult. I'm not going to say it's an easy, right? For those who have brother, sister, dealer, you can ask your koko. All right, struggling or not science stream, right? But it triggers you. It makes you think and look for the answer from a different angle. Think and solve instead of just memorize and going straight. That is not the purpose of science stream. Science stream is not supposed to ask you to memorize and vomit. Yet last time they say biology, chemistry, physics, just memorize and vomit. Syllabus have changed so much that you memorize also you still cannot answer the question. Understand or not? Yeah. So you need to know how to answer the question. That's why I've been training you guys since Form 1, Form 2, Form 3, how to answer the question. And these are the things that you need to bring towards higher. What you guys saying? I just went to toilet just now. Hey, watch recording. Just a small talk only on science stream. I hate problem solving. You need to solve problem when you go up next time. All right, you need to solve a lot of problems when you work in the future. Correct, problems that will always be there for you to solve. So you need to solve it whether you like it or not. Yeah, so don't be soft, toughen up. When it gets tougher, when the situation gets tougher, you become tougher. Understand? Can problem solve me? Students, apakah ini? Okay? Cannot. Yeah. Now, can one. I'm very, very sure that you guys can. Yeah, start in Form 3. Start in Form 3. Just think of your SPM journey begins in Form 3. Okay? Now, let's look. Astro, let's go back to chapter 12. I forgot to cover one small part in chapter 12. Can I cover this part? Can anyone take out chapter 12? Okay. All those who have chapter 12 in front of you, give me thumbs up. All right, all got. Now, let's go to page 1. What I missed out from last week's class was the mathematics part. All right. Just want to double check. All of you have a calculator with you. Can you get a calculator in front of you right now? Can all of you type out this thing? Do you know how to type out this thing out? Yes, no? All of you? 1.5 times 10 to the power of 8. Okay, what do you put? 10 to the power. What do you press to put the 8 up there? 1.5 times 10 to the 10 to the this one of 8, is it? Because different calculator is different. Okay, so if you guys know how to type out this one, then you're fine with it. You can do this next calculation. So this next part here, you all can. All right, if you're not to type out, can already, no problem. Okay, just want to make sure that all of you, mathematics got learned, right? Where, what? No faith. I don't know how your calculator looks like. You try to type 1.5 times 10, and then you see an arrow button at that one, and then 8. Is that what you type out in Max for your calculator? I know some of your calculator very chunky. My calculator, I'm still using this arrow. No. See what there's a oh, you have this thing. Or yours is 1.5 times 10x. Is this one? See the button again? Can I see the button? This is the new one. Sorry, I need to check. Yeah, x what on top here? Is it x like that? Is it a square or something like that? X and then 8. There's this button like that one. A small box, yeah. All right, so Norway, can or not? Check calculator, boleh ke tak boleh? Okay, that is first task. This is barely anything. I haven't even started my class yet. Okay, so now you know how to use calculator to find this one. Next, we're going to measure the distance. Now, from your house to school, of course, I can use kilometer. All right. But from your house to the sun, guys, we're not going to use kilometers. Because by the time you write kilometer, you're going to have so many 0, 0, 0, 0, 0 behind. Correct? That's why we turn it into a standard form. Mathematics, you call it standard form. Right? So, let's figure out. First of all, we're going to calculate the distance to the sun. So, astronomical unit is the first unit that we will learn. What is the distance? It is the distance between Earth and the sun. That means I want all of you to draw the sun over here, draw the Earth here, and then you are going to write this. Use a different color pen. All right, you're gonna draw this over here. This is called 1 AU, 1 astronomical unit, which is equivalent to 1.5 times 10 to the power of 8 kilometers. Means 1, 5, 2, 3, 4, 5, 6, 7, 8. That is how much? 150 million kilometers away. Understand? Yeah? This is considered 1 AU. So we measure other planets using this AU, astronomical unit. But this AU usually is very limited for a smaller solar system only. Because if I want to go further to infinity and beyond, I cannot be using AU anymore. I have to use a bigger number, because this AU can become even bigger and bigger. So that is when we're going to use another measurement called light years. Now, student, be very careful. Light year is not how many years. Light year is a distance. Okay, it's a jarak. It is not a masa, it is a jarak. Yeah, traveled by light in 1 year. So how fast can the light travel in 1 year? In 1 year, light can travel 9.5 times 10 to the power of 12 kilometers. Means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's a lot of zero behind. Understand that? Next up. So highlight. For 1 AU is 1.5 times 10 to the power of 8. 1 light year is 9.5 times 10 to the power of 12. Okay. Now, ready? We're going to move to the next one. So now that I've given you these 2 units, everything else is just mathematics calculation. To calculate, if I tell you planet A to planet B, all right, it is 5 AU. Means what? That means how far is A to B if it's 5 AU? Well, we know that 1 AU 是这个嘛，对吗？ Correct? So 5 AU means I times 5. Easy? Correct not? Or I give you a distance. I say that that planet is this one. A to B planet is 4.5 times 10 to the power of 8 kilometers. 4.5 times 10 to the power of 8 is how many AU? How many? Do you know the count? First of all, without using calculator, do you know how to frame your thoughts first? How do you write? It's basically like 1 apple is 1 ringgit, 2 apple is how much? Or 1 apple is 10 ringgit, 2 apple is how much? Okay, so what I want to do is, you can start writing. 1 AU is how much? The number 1.5 times 10 to the power of 8 kilometers. Now, how about 4.5 times 10 to the power of 8? So the same kilometers I put in the same area over here. So let's say given 4.5 times 10 to the power of 8. So what is x? So x is not supposed to find how many AU, right? So do you know how to find this one? You know, learn in mathematics, cross multiplication got learn or not? Got learn linear equation? Exactly how it is. You just times up, times up. Sometimes the formula makes students, right? Teacher, I just memorize the formula. But guys, sometimes formula like that, you memorize, how long can the memory stay? Why don't you use mathematics? All right, we do what you call your nisbah is called ratio, is it? You use your ratio to count. So much easier to understand. Yeah. I mean, yeah, but it's tiring. Once you frame your mind in this one, you can answer a lot of mathematics questions. Understand? Okay. So let me give you an example. Let me give you an example. Why don't you try this? 1 AU, you know, is 1.5 times 10 to the power of 8. 对吗? Why don't you type out for me? I say planet X is 3.2 times 10 to the power of 8 kilometers. All right, type out in the calculator for me and tell me how many astronomical unit is planet X. Use calculator. Oh, that's fast. Now, darab silang, cross multiplication, this one times up, this one times up. So if X came up here already, then the 1.5 have to go down the other side. All right, use calculator only. So for those who still needs to teach cross multiplication, 3.2 times 10 to the power of 8, you times up times 1, anything times 1 is the same number, right? X times up, X is here. Now, I want X alone. What you do, you're going to bring this down here. So that means 3.2 divided by 1.5. 对吗? Times 10 to the power of 8. Tell me what's your final answer. Astronomical unit should be point. It should be small number. It is not a big number. So obviously I'm teaching this one based on this. So what is your CC? 32 divide 15. Press and give me decimal place. 1.5. 2.13. Did all of you get 2.13? Double check. If you did not get 2.13, that means you've been pressing your calculator wrongly already. Those who got 2.13, give me thumbs up. Those who have found 2.13. Max found it. How about the rest? Yishin got it. Norfei got it. Dylan got it. Well, great job. Right, let's try another one. 1 AU is this. 3.2 AU. Planet X to planet Y is 3.2 AU. How far is it in kilometers? How far is it in kilometers? So 3.2 AU. AU, arrange them nicely in one side. Kilometers arranged nicely on the other side. Trust me, cross multiplication can never fail you if you arrange them nicely on the same side. So, what answer do you get? How many kilometers is 3.2 AU? So, X multiply 1 is X, which I want to find. 1.5 times 10 to the power of 8 times 10 to the power of 8 times 3.2. Wow, Max, your number so big. 48000. Are you able to change it to a standard form? Can I challenge you guys a little bit more? I know you guys get what? Max, can you give me the number again? 4, 8. How many zeros are there? 1, 2, 3, 4, 5, 6, 7. There's 7 zeros. Students, can you report this answer in standard form? Can someone type out for me? All of you, I want you to practice. Type this out in a standard form. You got learn or not standard form? Actually, I simply think, but got right. Got learn or not standard form? Oh, never learn standard form. Oh no. Okay. I thought they forced you to learn in form 1 already. Okay, so how do you change the standard form is, all right, because the zero ends here, right? So the decimal is here. right? So what we want to do is, we don't want to write so many zero. So what we do is we put all these zero and group them in this, as this. So that means we bring forward 1, 2, 3, 4, 5, 6, 7, 8. That means I stop at 4.8 because I want it 4.8 like that. And then times 10 to the power of, I move 8 times to the front. So I put 10 to the power of 8 kilometer. Itu sahaja. Understand not? Yeah. So I remove this headache. I turn it into something cleaner in reporting. Yeah. This is called standard form. Okay. Yeah. So teacher, can I write 48 times 10? Can. Then it's 10 to the power of 7 already, lor. But usually standard form is 4 point something like this. Is lesser than 10 right now. Okay. So the same rule applies for light years as well. Yeah. Except 1 light year is not this number. 1 light year is 9.5 times 10 to the power of 12. Yeah, so how I remember is usually, okay, I don't know about you guys. One way for me to remember, I will memorize, I will put, this is quite lame, but okay, just listen. This is how I memorize. I, ha, because 我发了, 发达, reach already. Now why I put ha, because, and for those who knows Thai language, right? I don't, but number 5 is pronounced as ha. Right? If you see the comment on Instagram and Facebook and all, and then you see the Thai people, they watch a comedy and then they put 5. For them, it's ha, and how sound. All right, correct or not? It's like us, we put lol. Okay, lol. They put 5. So I, ha, because reach already. That's all. 1.5 times 10 to the power of 8. Yeah, and then the other one, light year, I just extend this one. I change it to 9. So it become 9.5. Okay, just put a little note over here, 9, but now it's plus 4. Okay, so yeah, this is 8, 12, 4 pula. I add 4, so it becomes 12. Yeah, so that's one way to memorize. If you guys can memorize the number without helping, then it's fine. Okay, all right. So, homework, I'll let you guys do it. Please send to me your answers. I will check. When we come back, we will do a quick run through as many rounds as we can of the textbook and of all the questions that can come out. Can or not? But in the meantime, please, teacher, what's the HM again? Where? What's the homework? Okay. Homework is finish up all this latihan, and that's one. Number 2 is I will give you another extra homework. Yeah, I give you 2 sets of WASA format questions for you to try out. Yeah, and please do more exercises. You need to expose yourself. Questions are going to be so different in WASA standard really. Okay, so we stop here. I'll see you guys next year, which is in 2 weeks time only. Right, I'll see you guys in 2 weeks time. Thank you, students. I'll wish all of you Merry Christmas for those who are celebrating. Happy New Year. And I'll see you in year 2024. All right. Thank you. And you may unmute yourself and say a farewell. Bye-bye.
See you, Kenny. Bye-bye.
Good night. Good night.